Hello. We start with significance tests, and when we do them, they're very similar to the confidence intervals that we've already looked at. And the first step is to write out our hypotheses, look at the conditions, perform a calculation, and then interpret. And I'm going to break these down into their own videos. So first, we're going to look at the hypothesis. Now, when we state these hypotheses, there's two hypotheses. There's the null hypothesis and the alternative hypothesis. Now, the statement being tested is called the null hypothesis. That's the thing that we previously have thought of. Usually, the null hypothesis is a statement of there's no effect, or there's no difference, or there's no change from what we had before. The claim that we want to prove evidence for is called the alternative hypothesis. And every time we do a significance test, we're going to need a null and an alternative hypothesis. We write null hypothesis H sub O, and the alternative hypothesis we have a little subscript of an A. Now in the paramedic example, we want, from our previous lesson, we want to find the null hypothesis and the alternative hypothesis. Well, in our previous example, right here, we thought that the mean was going to be 6.7. So we start off and we write the mean is 6.7. So if nothing changes, that's going to be our null hypothesis. Now, what they're trying to happen is they're hoping that the time decreases. So it becomes less than 6.7 minutes. So that becomes your alternative hypothesis. Now, whenever you do this, you have to define what mu is. So over here, we have to say mu is the response time for paramedics. So we're saying the response time is equal to 6.7. That's our null hypothesis. And we want to prove that it's going to be less than 6.7. Now, hypotheses always refer to the population, not the particular outcome. Just like when we did confidence intervals, our parameter is talking about the general population. So make sure it's always in terms of the population parameter and not the statistic. Now, alternative hypothesis can be one-sided or two-sided. One-sided hypothesis either have a greater than or less than, where a two-sided alternative hypothesis is either going to be, it's going to be not equal to. Now, here's our one example that we're going to do. The question says, does job satisfaction of assembly workers differ when their work is machine-paced rather than self-paced? So they did a study that chose 18 random subjects, or subjects at random from a group of people who assembled electronic devices. Half of the subjects were assigned at random to each of the two groups. Both groups did similar work, but one's work setup allowed workers to pace themselves, and the other featured an assembly line that moved at fixed intervals, so the workers were paced by a machine. After 2 weeks, all the subjects took the survey. They switched work setups and took the survey again. The parameter of interest is the mean of the differences of the scores in the survey. And then they asked what design did they use, and this is a paired design, or match pairs, where they go through one and then they do the other and they flip-flop. Now the null hypothesis, so the parameter, we look back at the parameter of interest. We want to look at the differences in the studies. So our null hypothesis is that they're exactly the same. So the difference in the two would just be 0. So mu is the difference between machine pace and self-paste. And our alternative hypothesis here isn't that it's not going to be equal to 0. Now we don't know if it's greater than or less than, so we just say we just want to check that it's not going to be equal to 0. And that's what we use for an alternative hypothesis. All right, and that is hypotheses.